All right, welcome to another exciting episode here of Advanced Level Chemistry at Spain Park. Today is Wednesday, September the 18th, and we are excited that you're joining us all around the world watching these exciting videos. And if you are liking these, please feel free to subscribe to this channel and hit that like button. And so, anyway, we're starting in on a new unit now. We're starting into chemistry. Everything we've done so far has been all about numbers and measurements and how to take measurements and all of that. So now we're getting into the meat of chemistry. So here we are 4 weeks in, or however many weeks we are. So what is the definition of chemistry? It's right there at the top of your notes. Somebody will read that for me. Okay, go ahead, Mars.
The study of composition of substances and the change that substances undergo.
Okay.
It consists of all of what chemists do and what they learn from their experiences.
Okay. What does it mean to study the composition of substances?
Study of what they're made up of.
What they're made up of. Okay. So what are they made up of? I mean, that's just the real basics of what's water made up of. Well, hydrogen and oxygen. Well, it's 2 hydrogens and 1 oxygen. Well, what's sugar made up of? Well, it's a big molecule, 12 carbons, 22 hydrogens, 11 oxygens, all kind of bonded together. Are there different ways in which you can bond together? Are there different forms that have the same formula and do different things? And so that's it. Plus, then the fun part is, well, you know, what happens when you mix things together? When you're reading in pages that 8 and 9, or the history of chemistry, what was chemistry kind of born out of? Alchemy. What is that? I just read it. Didn't you have to read a novel about the alchemist or an alchemy? What, you know, was that about anything sciencey at all? I've never read the book, but they said it was. No? But it was set in the 15, 16, 1700s, wasn't it? Somewhere in that range? Okay. Anybody know what alchemy is, or what an alchemist would do?
I mean, it's like back then, like the philosopher kind of way they would mix different substances and try to change certain materials to like gold or something.
Yeah, that's exactly what it is. Did you guys hear what he said up front? What?
Mix different substances to turn into gold or silver.
Change substances into gold or silver. Now, back in those days, there was a lot of witchcraft and sorcery involved, and they were trying to make these brews and do whatever, and they could never do it. But they, you know, sometimes they mix stuff together, and they, oh man, that's not gold. Ooh, that was cool. What was that? You know. And so, out of all that mixing and trying to make something into gold, is there somebody at the door? Oh.
Seriously, yeah.
Yeah, I got it. Oh, here, do me a favor and just put all your answers just in blank, okay? So that was kind of the birth of chemistry, is just having all of that in there. So, but now we have the 5 divisions of chemistry, okay? The 5 divisions. It's just kind of breaking down the different things that a chemist might study, okay? And Kate, I'm actually probably going to ask you to be my clicker over here. Just so when I tell you, you can just sit in my chair. Okay, thank you. So we have the definition, just go ahead and click to the next one. We have the definition of chemistry, but then we have the 5 divisions. So the first one was organic. What did you find out that organic chemistry studied? Sophie?
The study of essentially all substances containing compounds.
That contain what element? Carbon. Okay? This is my introduction to organic chemistry textbook. This is what you would take as a sophomore in college if you're any kind of science, chemistry, medical, anything. You take General Chem 1 and 2, which is what this class really is. And when you take AP Chemistry next year, you can even test out of the Chemistry 1, Chemistry 2. Okay? But then you would take organic chemistry. This is just an introduction. But I mean, when you look at it, let me find a good page. You know, you just had end up having all kinds of symbols and structures, and I mean, my wife, we always tease that she's a nurse, but she loved organic chemistry so much that she took it 3 times because it was a challenge. And so, but it's the study of anything that contains carbon. Now, what I don't know. I've watched Star Trek and different things, but if you guys ever watch Star Trek, they always say, "What's the element that our bodies are based upon?" I know that we're 70% or so water, but what's essential for all living things?
Oxygen.
Oxygen to breathe, but we are what was called carbon-based life forms. Okay, that everything, all of our proteins, all of our cells and everything are all made up of carbon compounds. And so organic chemistry is really that living. If something's organic, it was living. It was life. So what's the source of all oil and coal on the earth? What do they say? Where did it come from? There's fossil fuels, but why do they call them fossil fuels? Well, what's a fossil? A dead animal, the remnants of something that was once alive. And so oil and coal and natural gas, theoretically, all came from dead dinosaurs or dead trees and all the plant life, okay? I kind of believe, that the earth was maybe created with pockets of oil and stuff in it that was already there. Just the philosophical question, if God did create Adam and Eve, which I believe he did, but we don't go there. But if God created Adam, did he have a belly button? Just something to ponder tonight as you put your head on your pillow, because that's the umbilical cord. So I mean, anyway, just a thought. If the earth was created and a tree was created, which came first, the chicken or the egg? If a tree was it created with rings? If mankind was created, and again, you believe whatever you want to believe, but if he was created, was he created as a baby or as a man in his prime, in his probably mid-60s? just being, I'm just trying to be optimistic here a little bit. In my prime, I'm in my prime. Just things to ponder, So could there be an appearance of age is all I'm just saying. But that's for you to just kind of work through on your own. Now, so organic chemistry is that study of anything that was alive. So oil and natural gas all came from things that were once alive. So they're all based on carbon. There's long hydrocarbon chains. And so we talk about hydrocarbons. So inorganic chemistry is going to be what? What did it say inorganic was?
Carbon.
Things that don't have carbon, everything else. And that's what we're really going to focus on in here is the inorganic chemistry. What about analytical chemistry? What's the name make it sound like? Numbers, but what else? Say what, Mia? Analyzing what's in it. If you want to be a forensic scientist, and probably if I came back in another life, a forensic scientist sounds like it'd be pretty cool. Because you get to be a puzzle solver, I don't know what shows you guys watch on TV or anything now, but NCIS was real popular way back in the day. And Abby Shudo was the forensic scientist that would go and they would have, come in with some mud or something on the shoe near the crime scene, and so she would have to analyze it, try to figure out, are there any clues in that to help, figure out? Or, I'm watching it's really kind of a corny show, but it's a Canadian show called Hudson and Rex. It's about a detective and his dog. In that, a guy died just in the episode I was watching too late last night. My fire alarm in my house, you know, the smoke detectors are all connected to one another. At like 11:30, just the whole house went off. You know, I mean, it's loud, and then it just went off after like 3 seconds. Scared the fire out of me, because you know, I'm just like, and then I'm going up here and looking all around the house trying to figure out that it does it again. You know, 3 seconds. I look everywhere, there's no smoke, no fire, nothing out of the ordinary, and so then I'm afraid to go back to sleep because I don't know what's going to happen. So anyway, I was watching that silly show, but a guy died by a snake bite, and the forensic scientists had to go through and do the blood test and figure out what type of snake it was, you know, that it was a black mamba, that, you know, and go through and try and figure out and piece together. So a forensic scientist sounds like, to me, it'd be a pretty interesting job. You know, analyzing and figuring stuff out and trying to help do that. But, you know, I don't know what floats your boat. The next one, what's the next one in the line? The physical. And y'all watch Oppenheimer? Okay? Those guys, they're the physical chemists. They're the theoretical ones. And PChem is a junior level class, but it's one of the hardest chemistry classes you're going to take. It's a combination of chemistry, physics, and calculus all rolled into one. Okay? And when I took it, and I took another class called Physics of the Atom, which I really needed 4 semesters of calculus to even think about understanding how to do it. It was all very math, theoretical basis, and that's what Oppenheimer, and that's what all those guys that were coming up with the bomb and all of that were talking about. So they're the Einsteins, you know, that are just your brainchilds. They're very theoretical, getting down into the various, what makes up the atom itself, how is it, what are the forces in it, how can we control it, how can we manipulate it. You got to be super smart and have a lot of math in order to be able to do that. What's the next one?
Biochemistry.
What do you think? Biochemistry. What's biology the study of? Life. So what is biochemistry? The study of the chemistry of living things, right? So what other field do you think goes hand in hand with that one? Medical, but I mean, of the divisions of chemistry that we've already talked about, which one do you think you're going to need a lot of to do biochemistry? Organic. Organic chemistry is huge, especially if you want to be a pharmacist. A lot of people, you know, it's a great profession, good money, you know, and you don't have to be like a doctor. You don't have to be on call quite as much. You get a little bit more standard hours and just be able to be that pharmacist. But you take a lot of organic chemistry, a lot of biochemistry to be that. And then what was the last one? Or was that the last one? Okay? So those are just some divisions. Those are just things for you to think about as far as what you might want to do. Okay? Now, go ahead and click. Okay, so there they all are. If you don't have them written down already, but those are all right there in the book. It's just copied pretty much right out of the book, so you have access to that. Okay, so go ahead and click. Now, we've all heard about the scientific method. The reality is there isn't one scientific method. It's all, there's many different ways, but here's the key. They all start with this. There's got to be an observation. There's got to be something that you see that you want to make some kind of hypothesis about, some kind of educated guess about, some kind of, oh, I wonder why that happens. Okay? And then you go through. Now, just the only thing I want to clarify is the difference between, you know, a hypothesis is an educated guess. A theory is a thoroughly tested one. But here's the difference. Okay? A scientific law summarizes observation and experiment, but it only describes a phenomenon. It can only describe it. Okay? We can talk about gravity as far as we know it falls down. Okay? The law of gravity tells me that, you know, that there's attraction between any two masses, and the closer they are, the stronger the attraction. Okay, and we kind of talked about that already with our weight, F equals ma, and all that, and the attraction to the earth. So we can describe all the characteristics of gravity. But why is there gravity? There's theories about why there might be gravity, but nobody really knows why we're attracted to the earth. It's just one of the 4 fundamental forces that just is. They're just gravity just is. Okay? Laws describe it, A theory tries to explain it. Okay? Laws only describe natural phenomenon. Okay? And it only takes one experiment to prove. We have many theories all throughout history that we thought for sure were true. It's true. And then along comes another experiment, we learn more technology, and bam, okay, let's modify that one. Because it only takes one to disprove it. All right, so click. We also learned out in your textbook, when you look on page like 5, I think, or 4 or 5, it went through the different areas. And in your book, it talked about basic research, applied research, and technology. Well, I put applied research and technology, and I just changed it from research to chemistry. But pure chemistry is knowledge for knowledge's sake. That's what Marie Curie was doing when they were studying the radioactivity. They were just fascinated by this new thing, this radioactivity. And they just called them alpha particles and beta particles because they had no idea what they were. And so they just kind of had to study that. Ernest Rutherford. Has you guys ever heard of Ernest Rutherford and discovering the nucleus with the gold foil experiment? Well, he wasn't trying to find the nucleus. He had no idea. He had no interest in finding the structure of the atom at all. He was fascinated with radioactivity. He was trying to figure out what was going on with radioactivity, and we're going to study that later on. But that was just pure science. And the best example of this is when I was in college, every senior in my college had to do a research paper, a unique paper. And a guy on my wing, he was in pre-med, he was going to med school, but he was a senior, I was like a sophomore. And his paper titled, it was something about the rectal temperatures of hibernating nude mice. Something going on, some relationship with that. Okay? I said, like, seriously, dude? First off, it's a nude mouse, which means it has no hair, so it's running around its whole life kind of already a little insecure, just being called a nude mouse. Number 2 is just trying to get a nap. And you know how they take the temperature for animals, so very rudely getting woken up from a nice hibernating nap. For what purpose, okay? Pure science, okay? I'm sure there was something of value that he was trying to get out of that, but I just thought that the title of his paper just says, and that was 40 years ago, and so I still remember it just because it was so crazy. But then we want to take what we learned and apply it. But then again, what we learned, what Marie Curie, what Ernest Rutherford, and all they found out about radioactivity, we can use it then to power submarines. We can use it to supply clean energy to people's houses. We have 2 nuclear power plants here in Alabama that supply energy for us. It's actually the cheapest way to supply energy on a day-to-day basis. Okay, but we can also use it to destroy the world, with an atomic bomb. So applied science, has a lot of, pros and cons to it. All right, so that's all that front page. That's all just really basic stuff. So let's turn the page, and then we get to the 3 phases or states of matter. And you have a whiteboard now in front of you. And I want you on that whiteboard to, and if there's only one in between 2 of y'all do it between the 2. I only have a limited number. If everybody can have one, that's great, but share with a neighbor if you don't have one. If your marker doesn't work, I have a marker here, okay? But I want you to use 10 circles to represent an atom, okay? 10 circles to represent an atom, and I want you to do 3. I want you to show me a solid, I want you to show me a liquid, and I want you to show me a gas. What you think, how are the atoms going to be arranged with a solid, liquid, and a gas? Okay?
10 for each.
10 for each. Okay? This is just kind of get your idea what you think. Do y'all not have one? You do? So you use 10 circles to represent what a solid would look like, what a liquid would look like, 10 for a liquid, 10 for a gas. classic. You got the whole board. And then you could cram it
Well,
a little
I started
bit.
to draw it, and I was gonna draw bigger, but then I was like, I don't know how to define this board into 3 parts.
Just make sure it fits. I mean, look, but look, you're not going, he did it all purpose. I'm looking there, they're all cramming it in on the top. That's what I want to see. Use the whole board. Make it, help an old man out. I mean, a guy in his prime.
I think, Hobbs, I think you're the same age from
Thank you. I had a joke with, I have a bunch of friends, you know, all my age or whatever. We have a joke, you know, that, you know, because I think one of the guys said, you know, we're in our middle age, and the wife said, yeah, we're not middle age anymore. You know, we're a little bit on the other side of that one, you know, but at 65 is when you have to go on Medicare. You get the government insurance, you know that. And I have, in about 3 months, I have to apply for that. And so to me, I'm still middle aged. To me, I'm middle aged until my insurance card goes red, white, and blue. Goes Medicare, you know. So I'm on the very high end of the middle age, you know, that middle bracket.
Maybe that's not any, everybody on one side of the family is very young.
Yeah.
And like.
Yeah. So during this year, you'll see me transition from middle age into official senior citizen. Yeah. At least I get coffee at McDonald's for 10 cents cheaper. We got it? All right. All right, so here's kind of a classic example right here. A lot of y'all's may look like this. Okay, so we have the solid kind of all together, right? Now, what are some of the characteristics? And you can see, this is for kind of filling in these blanks here, but what are some of the characteristics then of a solid if you drew it like this? And what are some of the things that you can see about, let me get this, since I'm supposed to be videoing here. What are some of the things that you can see about the solid the way he drew it? They're close together, right? So wait. Okay, but what does that mean about their density? If they're closely packed, that means more dense. So solids are generally pretty dense, okay? Have a high density because the atoms are packed together. Now, are they arranged in an orderly or a disorderly pattern? Orderly. Okay, so do we know what word describes things that are in an orderly pattern?
Structure.
It is structure, but there's a uniform, okay? But it's not more sciencey term. It's not really sciencey. It's a word you've heard your whole life. Okay? Have you ever heard of something being called crystalline? A crystal? Okay? So if something is a crystal, we say that it's a crystal lattice structure. Most solids, okay, have a crystal lattice structure. Now, crystal means orderly arrangement. Okay, so this is all kind of characteristics of a solid. It may not all fit on the lines, but you have extra spaces around the line you can kind of fill in. But it's an orderly arrangement. Have any of y'all ever heard of the term lattice around your house? Any of y'all ever have any lattice work? You know, the little wood, that 4x8 sheet that it has the crisscrossing wood that maybe is under a deck. Maybe it's maybe on a fence or something that roses can grow up on, or vines. You guys know what I'm talking about? It kind of has the crisscrossing wooden panels, kind of look like that.
Oh yeah.
Okay, it's got the little 1 or 2 inch slats that just kind of go crisscross. It's that repeating pattern. Salt has a crystal lattice pattern. It's an orderly arrangement. You have your Cl minus and your Na plus and your Cl minus and your Na plus. But it's the same pattern that repeats itself over and over and over and over again. Crystalline means it's orderly. Lattice is that repeating pattern. So this is a model of a diamond. Okay? This is a model of a diamond. It's a orderly, or you can see each black sphere is a carbon atom. Okay? I tried to get this for my wife. I figured with the right setting it'd be nice big diamond, but she didn't kind of go for it. But you can see now this is also a crystal lattice structure. This is graphite, which is your pencil lead. Okay, it's still an orderly arrangement, but it's a different type of arrangement. So graphite has different characteristics than diamonds, but there's still an orderly arrangement, a crystal lattice structure. All right, we'll continue on that tomorrow. Go Jags.